Welcome all. I'm thankful to you for showing a great response to my YouTube classes. And today's class is on vapor pressure cavitation. Okay, so I'm not going to give you all the details which I had explained very clearly in our plus classes, but basic what is the consequence, how it is happening, basics I'll be explaining to you, and I'll be doing one experiment also in this video. So I have got some setup, and let us do some experiments so that you have a physical understanding why it is happening. Before we go to this, let us take water molecule. This is our water molecule. Understand carefully. This is our water molecule. And these bonds are known as covalent bonds, and they are very strong. And these bonds keep water in its complete position. Now, let us take some other molecule, water molecule only, other water molecule, and these are in liquid state. Okay, now please observe here. Okay, no problem. And these are known as hydrogen bonds, and these are known as hydrogen bonds. These bonds are known as hydrogen bonds, and please try to understand carefully. These are covalent bonds. They are very strong, and they do not vary with respect to temperature. So, but these bonds are very weak. These are very weak. If I increase the temperature, these bonds break. Now, this is in the liquid state. So, the hydrogen bonds are keeping the liquid intact. But if I increase the temperature, these hydrogen bonds are broken. And please note on that this is undisturbed. This is undisturbed. These hydrogen bonds are broken and they move apart. That's why when you are heating, what is happening? The liquid is converted into vapor, because in liquid state, these hydrogen bonds, they hold together and they are very weak. If I increase the temperature, these bonds are broken and thereby they move apart. Exactly. So what is exactly happening? Let us see. So why, and you know, my dear students, let us take. So I'm not giving you all the details, but I'll give you a physical understanding to what exactly is happening. Now, let's take, okay, right. Dekho. Now, let us take a closed container. So I'm not going to explain you what is evaporation, what is boiling, all those I had explained in my regular class, but just an understanding to this cavitation vapor pressure I'll be discussing in this class. Okay. Let us take a closed container. This is a liquid surface. Let us take water. It need not be water, but any liquid. And you know, the molecules have got different kinetic energies, and actually that kinetic energy will follow some statistical distribution. Some molecules have more kinetic energy, some molecules have less kinetic energy. That's why the average kinetic energy is a representative of your temperature. I mean, temperature is a representative of average kinetic energy. So therefore, if I, now, these surface molecules, they escape due to additional translational energy, and thereby they become vapor. And all these consequences I had explained in our RAC. So let them escape. Now this is known as evaporation from the surface. And some molecules, they have less kinetic energy, they rejoin. Higher kinetic energy molecules, they leave, and lesser kinetic energy molecules, they rejoin. So the process of evaporation and condensation will continue until the equilibrium, that is dynamic equilibrium, is reached between the rate of evaporation is equal to rate of condensation. When both become equal, it is known as dynamic equilibrium. Under that dynamic equilibrium, now please observe clearly. So when the rate of evaporation and rate of condensation is same, there are some sets of water molecules, vapor molecules here, and they exert pressure on the surface. Under equilibrium, whatever the vapor is exerting on the surface, we call it as vapor pressure. And this vapor pressure is and some people call it as saturated vapor pressure or simply vapor pressure. So what is vapor pressure? It is the pressure under dynamic equilibrium when the rate of evaporation is equal to rate of condensation at a given temperature. So this vapor pressure depends on what? It depends on two parameters. One is the nature of liquid. Different types of liquids, they have different vapor pressures, and the other is temperature. So if I increase the temperature, the molecular activity increases. As the molecular activity increases, the rate of evaporation increases. When the rate of evaporation increases, more molecules escape and more molecules start exerting pressure on this. That's why the vapor pressure increases. So vapor pressure increases with increase in temperature, decreases with decrease in temperature. Why does it increase? Because at higher temperatures, there is a large molecular activity. Dear students, one more thing now. Okay, now dekho. So I'm going to do a beautiful experiment like how bubbles are formed and how they are collapsing. What is the consequence of this? Beautifully we'll see in class now. But you need to wait till the end. I'll do this experiment till the end, and suddenly don't switch to the last, because without concepts you don't understand, because you should have a lot of patience to achieve something great. Now in thermodynamics we have seen on TS diagram, this is a constant pressure line corresponding to P1, where it cuts saturation, we call it as saturation temperature. And similarly, at a pressure P2, this is a constant pressure line. At a pressure P2, this is saturation temperature T2. Now, what is your observation? Compared to P2, P1 is more. Compared to T2, T1 is more. Means as the pressure is increasing, the saturation temperature is also increasing. So, please look at, if the same thing is plotted here on pressure temperature graph, you will get something like this. How, sir? If this is P1, this is T1, this is P2 and this is T2. Compared to P2, P1 is more. So this is my P1. Compared to T2, T1 is more. So therefore this is T1. So this is my saturation curve. This is the saturation curve. And one more thing. If you take this point, my dear students, let us call it as A. And let us take this as B. So can you tell me what is the pressure on this line? It is a constant pressure. It is a constant pressure on TS diagram. The same constant pressure line I'll show by a horizontal line. So where it cuts this saturation curve, we call it as saturation temperature. Let me show you like this. This is one temperature, this is the pressure, and you know, my dear students, this is a constant pressure line, because on a vertical axis I have taken pressure, therefore it is a constant pressure line. So this is a constant pressure line, the same line from TS diagram I am showing it on PT diagram, and where it cuts saturation, so constant pressure cutting saturation, we call it as saturation temperature. So constant pressure cutting saturation, we call it as saturation temperature. Very good. This is the saturation temperature for this particular pressure. Now please observe here, my dear students, if you observe, look at, so if you take particular pressure, this is one particular pressure, and this is saturation, and let us take this as A and let us take this as B. What is the temperature of A? It is less than, temperature of A is less than saturation. So for a given pressure, everywhere the pressure is constant. For a given pressure, the temperature of A is less than saturation. This is saturation, less than saturation means left side. So at the same pressure on the same pressure line, this is my point A. And you know this is a liquid region. So whenever the temperature is less than saturation, it will be in the liquid region. So now at B, the temperature is more than saturation. This is saturation more. So as the temperature is more than saturation, so this is more at a given pressure, and this will be in vapor state. So this is in vapor state. So please, the broad idea is, if this is the temperature, this is the pressure, and this is the saturation curve, this will be the liquid region and this will be the vapor region. So there is no problem with this. Now, with this information, I'll take this graph and let us proceed, my dear students. Look at. 1 second, please. See, let us understand conceptually. Now, I have taken this. Dekho ek baar. Let us take the temperature and pressure, and this is our curve. In order to boil, what do you mean by boiling? Conversion of liquid to vapor. In order to boil, that is liquid to vapor, there are two ways. You might have seen in our regular kitchen, you keep water open to atmosphere and you heat it, and you will be seeing water boiling. So what are you doing there? The pressure is atmospheric, it is open to atmosphere. At the same pressure you are heating. It means to convert from liquid to vapor, one procedure is keeping the pressure constant and increasing the temperature. Okay, let us try to do that. Dear students, let's try to do that. Now, so let us keep pressure constant. So this is our liquid, and okay, I'll change the color, sirs. We'll take this. It's not good. We'll take this. Yeah, this is our liquid and this is our vapor. Now please understand, let me take this. This is our PT diagram. Now this is the liquid region, this is the vapor region. So one way is you are heating water at atmospheric pressure. I'm not changing pressure, I'm heating, so I'm increasing the temperature. So we have a liquid, let us say at this state, the pressure is constant, and please, at the same atmospheric pressure you are heating. So when I'm heating means the temperature is increasing, I'm moving to the right. So when the temperature is increasing, we have reached the saturation state, and thereby liquid is converted into vapor. So this is one procedure. One of the ways of converting liquid to vapor is at a constant pressure you heat. At a constant pressure you heat, the liquid is converted into vapor. And let us see the second procedure. What is the second procedure? The other procedure is fix the temperature. Dear students, you fix the temperature, and let us say this is the temperature. I'll take the other graph. एक काम करते हैं. We'll take the eraser. Yes. Right. Now, dear students, एक बार देखना. Let us take the other case. This is T and this is P. So now the other way, this is liquid and this is vapor. Keep that. In this case, you kept pressure constant, and you have varied or increased the temperature. That is normal heating. This is general boiling, which everyone knows. But the other boiling is you can convert liquid to vapor the other way also. How, sir? Keep the temperature constant. When the temperature is on this axis, so keep the temperature constant. So now I am lowering the pressure. Now I am lowering the pressure. This is the pressure. This is the pressure. I am lowering the pressure, lowering the pressure, lowering the pressure. At some point of time, it is reaching saturated vapor pressure. This is saturated curve. So at some point of time, my liquid is reaching vapor pressure. So if you reduce the pressure below the vapor pressure, so liquid is converted into vapor. Now I will give you the physical explanation why at lower pressures, when the pressure is reduced, why the liquid is converted into vapor. Now I will give you the demonstration physically with this. Dekho, when the pressure is reduced at the same temperature, I am not changing temperature. At a given temperature, when the pressure is reduced, at some pressure, that is vapor pressure, at saturated vapor pressure or vapor pressure, now my vapor bubbles are formed, and thereby my liquid is converted into liquid. Means whenever the pressure is less than vapor pressure, this is the vapor pressure, at a given temperature, whenever the pressure of the liquid becomes less than vapor pressure, my vapor bubbles are formed. Let me repeat. Whenever the pressure of the liquid, ये तो liquid state में है, ये gaseous state में है, this is liquid, this is gaseous. When the pressure is less than vapor pressure at a given temperature, some point of time it reaches saturated, and below the vapor pressure, my vapor is formed. Physically क्या हो रहा है sir? You are decreasing the pressure. When you decrease the pressure, why vapor bubbles are formed? Let us see the physical explanation for this, sirs. Let's see the physical explanation for this. Means whenever the pressure is less than, 1 second, sirs. 1 second, please. I am excited to show this. 1 second, please. Now, look at, sirs. Look at. 1 second, please. I am sorry. Now, this is the temperature, this is the pressure. And what is this? एक particular temperature ले लेंगे, sirs. Let us take particular temperature. This is anyone vapor pressure or saturated vapor pressure or vapor pressure. Our liquid is at this state. Look at, our liquid is at this state. ये तो liquid है, ये तो vapor है. When I am reducing the pressure, look at the same temperature, reducing the pressure. Once it reaches vapor pressure, whenever the liquid pressure is less than vapor pressure, you have vapor pockets, vapor bubbles formed. Now let us see the beautiful explanation for this. एक simple example दूंगा sir मैं. Look at, sirs. Let us take water. Now let us decrease the pressure. This water is at this point. मतलब ये pressure is corresponding to this. This pressure is corresponding to this. It is in liquid state, so pressure is above vapor pressure. Now, if I cause the suction by pulling it up, if the piston is pulled up, what does it mean? It means suction. It is something like this. इधर देखो. If I pull this, इधर देखो. If I pull this, look at, it is suction. Suction means what? Low pressure. I'm pulling it. So therefore, it is suction, low pressure. So therefore, now when I'm pulling it, what is happening? Now it is expanding. When it expands, look at carefully. When it expands, look at carefully. These are weak hydrogen bonds. When it expands, these bonds are broken and they move. So during the process of motion, when they move, when they move apart, now bubble is formed. Which bubble? Vapor bubble is formed. क्योंकि initially, देखो एक बार, initially, all are packed. So all these are, देखो, please understand. देखो एक बार. So all these are packed. When I decrease the pressure, when I suck it, what will happen? It expands. When it expands, these are broken, and thereby something like hollow is created. When they move apart, now vapor bubble is created. Vapor pockets are created. This is nothing but low vapor pressure bubble. Means you can boil the liquid even at low temperatures by reducing the pressure. Whenever the pressure is reduced, when you are sucking it, when you are reducing the pressure, the molecules, they move apart, and thereby the bubble is created. Vapor bubble is created. So please understand this vapor bubble. Now I will show you beautifully. Now please look at the experiment. Let me do it. Now look at, for your understanding completely, there are no air pockets. You may be saying air bubble is there, sir. पूरा देखो, पूरा press कर दिया पे, पूरा completely it has reached this. No. Now I'm dipping this completely. Listen, I'm dipping this completely. अब देखो, look at, sir. When I dip it completely, look at. Now I'm sucking. Now, oh, देखो. Now let me show you again. Now I'm sucking it, देखो, creating low pressure. When the low pressure is created, they move, it expands. When it expands, now thereby local hollow region is created. That is, bubble is created. Look at, sirs, look at. Oh, I'll show you again. Now I'm sucking. Low pressure is created. अरे देखो एक बार. Clearly I can see, but I don't know whether you're seeing it. इधर देखो. Let me show you clearly. Now देखो एक बार, नहीं दिख रहा आपको? Yes, I can see very clearly. I don't know whether you can see it. देखो, you can do this. Yes. When it is sucked, low vapor pressure pockets are formed. Therefore, when it is sucked locally, the space is created, and thereby the bubble is created. What will happen to this bubble? Let us take this bubble. This is a low pressure bubble. It is a low pressure bubble whose pressure is less than vapor pressure. Low pressure bubble. And if this bubble, यहाँ पे pressure कम है देखो, and if this low pressure bubble is carried to a region of high pressure, if this is carried to a region of high pressure, now I am carrying this to high pressure, क्या होगा sir? It is surrounded by high pressure. Let us say this is some metallic surface. It's something like this, my dear students. अभी मैं शो करता हूँ sir. Listen carefully. अभी मैं शो करता हूँ sir. Please listen. Now let us say these bubbles are formed low pressure, because in venturimeter you see at the throat the pressure is very low. When it is less than vapor pressure, these bubbles are formed. When they are carried to a region of high pressure, तो ये low pressure का है, and if it is carried to a region of high pressure, what will happen? It's something like this, my dear students. Now if you observe clearly, एक सेकंड मैं बताता हूँ. If you observe clearly, ये भी demonstrate करेंगे sir. ये भी demonstrate करेंगे. Let me demonstrate this also. Now I have something like this. Now I will keep weight. इधर देखो, एक weight और weight लगाओ. You keep some more weights. So if I keep more weights, it will get crushed. So now therefore, when it is carried to a high pressure, this high pressure and this low pressure, and thereby what will happen? These will collapse, and that is known as implosion. Implosion का मतलब, explosion means outwards, implosion means inward. अब ये पूरा inward. High pressure, what is happening? When it goes to high pressure, when it goes to the region of high pressure, it is a low pressure, and due to mechanical inequilibrium, and this will collapse. When it collapse, कुछ नहीं है sir. यहाँ पे पूरा ये collapse. Let us say it is kept on some surface. So if it completely collapse, it's something like weights are falling. इधर देखो, एक second. Something like weights are falling. देखो. Now let us assume this to be a bubble. Let us assume this to be vapor bubble. And देखो, high pressure. And ये पूरा collapse हो जाएगा. पूरा collapse होने के बाद ये पूरा weight यहाँ पे surface पे आएगा, metallic surface पे. पूरा जब weight इधर नीचे गिर के आ गया. So now what will happen? When this weight, this pressure, severe pressures are created, even shock waves are generated, and thereby the metal is eroded, and which we call it as pitting. So therefore, this cavitation is a low vapor pressure low pressure phenomenon. Because when the pressure is less than vapor pressure, आप देखो, I'm sucking the fluid, I'm creating low pressure. इधर देखना, when the low pressure is, oh, you can see clearly, and these bubbles, when they are carried to high pressure, and due to implosion, severe pressure pulses are created, and thereby it may damage. So this is, and if you want a detailed analysis, I explained what is evaporation, what is boiling, all these I had explained very clearly. Thank you, my dear students. We'll come up with some more good videos. Thank you. God bless you.